Hello all, today we are solving LeetCode problem number 2976, minimum cost to convert string 1. So we are given two strings of length n and it contains all lowercase letters only, and the two strings are, one is named as source and the other one is target, and they have also given two arrays basically, that is a character arrays which is original and changed, and now they are given one more array which is a cost array where cost of I is the cost of changing characters, that is from original of I to changed of I. So to do this operation, to change this operation, it charges cost of I. So now you are used to convert the string source to string target. So basically you are given two strings, right? Source and target. So your aim is to convert the source into target by performing operations by using the cost, right? And now return the minimum cost for the conversion. I'm sorry about that, conversion, right? So what did exactly this mean? In order to convert the source into this target, we consume some cost of I, so we have to return the minimum of cost of I being consumed for this conversion, right? So that is all about the problem. So let us now understand with the first example. And also you can see here there is a note given that if original of I is equal to original of j, then changed of I, okay, which means there they have just mentioned that there might be an index which is same. uh, there can be two characters, for example a b present in original and changed as well. So for that, uh, there is no requirement for the conversion, right? So yeah, so with that saying, let us run into the example one. So by this, I have separately written the mapping here because we have uh, this, oops, yeah, so we have this changed and this original as given separate character array, right? So we can convert from original to changed. So that is what I have written. A can be changed to B and B can be changed to C. So I have completely written that. And cost of I, so this is the cost for conversion of this particular one, followed by this and everything, right? So I have written down these. Now you have to find the minimum operation, right? So one observation here we can say is, for converting C to B, I mean changing this C to B, uh, we have the cost here as 5, right? And there is one more way as well. First, to convert C to E, which cost us 1 cost, and then E to B, which cost us 2 cost, right? Which is nothing but 3. So minimum of this and this is nothing but 3. So with this saying, we can uh, see here that I mean there are nodes. Basically we can consider each character array characters as node, and there is a cost which is nothing but the edges value, right? So this appears to be a graph. So we can build a graph out of all these values: changed, original and cost. So by using these three, we have from node, to node, and the cost, the weight of the graph, right? So using this we can create a graph, and the goal will be to find the minimum length to reach the destination. So this is nothing but the shortest distance, right? So which we can find using BFS, but this will not be a normal BFS, this will be Dijkstra's BFS, right? So that is the approach which we are going to follow here to get the output. So first thing is constructing the array. So the first part of this solving the problem will be constructing the graph. So what exactly this mean? Construction of adjacency list. So here I am not showing of how we would construct this adjacency list, because that is pretty basic. So let me run through by creating the graph basically. So we have these following details, so I will write it down. Right, A can be converted to B, which is A to B, and B to C, then C to E. So this cost us to 5, and C to E is 1. C to B, okay, C to B is 5, and then E to B is 2, and D, there is one more D, which is 20. So this is the formed graph. So how could we represent? We can represent this by using the adjacency list, where we have the representation in the form of a key value will be from will be the key value, and the two node and the weight will be the pairs formed, right? So this is how we form the adjacency list, which represents the graph in fact. And now we have two strings, so let me write them down as well. So source is A, B, C, D, and target is equal to A, this is ACBE. So let me change the color, yeah, blue. So now we have same words in source as well as target. So we will come to this B, the second index value 1 at index value 1. So now conversion of B to C. So B to C, clearly there is only one way here, so which will cost us 5, right? So let us track down this as total is equal to 5, and now we are at this position C, and this is B, C to B. So C to B, from C to B there is this particular path which cost us 5. So C to B can be 5, and here we can note again one more path, which is C to E, and E to B, which is nothing but 1 plus, which costs us 1 plus 2, and minimum among 5 and 3 is 3. So added with total 3 is equal to 8, right? So now we are in the last part, which is D to E. So there is only one way of conversion, which is D to E is costing us 20. so we add with 20 here, resulting in 28. So this is the minimum cost. That is what exactly the output here they are returning here, right? So there is one edge case to be noted. So we have these mapping, right? So these mapping as a result of the three values, which is changed and original and the cost. With based on this we could able to form the graph. So what if there is no path, or there is no path to reach a node? Example, there is from B to A, or C to A. So is there any path here? There is no path here given in this complete mapping, right? Even if you check in this graph, there is no path, because we can go to C, E and come back to B, and then D. There is no way you can go back to there is no incoming edge into A. So because of that, in this case you have to check if there is no mappings available. You have to return -1 in that case. So altogether, how do we do this? First, construct graph adjacency list. Right now, write down Dijkstra's PFS algo, which will return us uh, the uh, the minimum dist with node, right? So, and lastly, iterate on both strings and use a map to track down the mappings. And because this reduces time, right? So with this, then calculate Dijkstra's PFS from a node to the destination, right? You calculate that and append that to map, and finally you will return the minimum distance to reach the destination, which is nothing but the operations of conversion, right? So with this saying, let us go ahead and code this up. The first step for the coding is to build the graph, or which is building the adjacency list. So graph equal to default dict of list. Now we are using zip function to zip original, change and cost, and building the adjacency list, right? So for O and O for original, C for change, and E for cost. Zip this is original, change and cost, right? So now graph of O dot appending the tuple, this is C and E, right? So now we are done with that. Now we have to define the Dijkstra's algorithm. We have to pass in the start point, right? Because in the usually we used to have the start point as 0 and the value will be 0, because the destination will be from 0 to the n minus 1 node, or the last node destination, right? So but here we have to mention the start point, because we have a as the start point, sometimes we have b as the start point, and sometimes c. So it varies. So from c to the destination is what we need, that is a to source to target, a to a and b to c. So the target varies, so we need the start point, right? So because of that, we have the parameter as start. So I will come to this part later, but now comes the very important part, right? Which is nothing but how do we process the complete source and target array, right? So first we will iterate. So for we will use the same zip function, yes, which is source, and t in zip target, right? So now if yes equal to t, we just continue because there is no operation required, or there is no cost required for the conversion part, right? So continue. And now if yes, the main thing which we are here we are using is in all time, I mean in every time we are not calling this Dijkstra's algorithm, because we have only 26 alphabets. So we will have a different map for each unique characters. So because of that, we will have a map called min cost. So this will track down cost for unique integer, right? So sorry for the brightness. Yeah, so we will have this map, and this will have 26 of 26 size usually, because we do not need it to calculate every time. Because for example, if we have if this b is repeated, b to c conversion is repeated within the source and target, we can reuse the same map, and we could avoid running the Dijkstra's algorithm once again to reduce the complexity. So because of that, if yes not in min cost, right? So in that case, min cost of yes is equal to, you call the Dijkstra's algorithm, yes, right? And now you have to check the same thing. If we have to check if t not in main cost, in that case there is no path available. For example, c to a, there is no path. So if a is, I mean, which means c to a, right? So in that case yes will be a and t will be c, right? So let me write it down. So yes will be a and t will be equal to s will be c, sorry, c and t will be a. So source is c and target is a. So this conversion is not at all possible. So if we check t in min cost, we will not have any particular entry in min cost, which means in that case you have to update with minimum -1, right? So if t not in min cost, this in this case return -1. So this is what it is. And now in the last case, you will have the min cost, right? So what do you update here? Here you will anyway update the the distance tuple, right, which will have the node and the distance. So that is what the outcome of the Dijkstra's algorithm. So in that case, you have to calculate the total. So each time when you calculate this, you have to add the min cost of the source and target, right? The what is the min cost which is taken here. So in that case, total is equal to min cost of yes and t. So you are append the total value, which means the node to node. For example, A to B cost is something bx, and B to C cost is y, so the total will be x plus y. So that is the case here. And now after running through the complete source and target string, you can return total. So this is the case, and now we have to write down the Dijkstra's algorithm, right? So here we will start with the heap. So heap, let that heap be pq, priority queue. I'll name it as pq, and we start at 0 position and start, right? So now we also have the dist map as this is also will have start as the key and the node as the value, right? So now while pq, we have to pop the anyway the minimum heap will be returning the min value when we pop. So we have current cost and node is equal to pq, I mean heap q dot heap pop heap. No, this will be pq, sorry. So if current cost is greater than dist of node, in that case you continue, right? And now we have to iterate through the the graph node, right? And then we will be performing, getting the new cost based on the Dijkstra's algorithm, right? So now for in that case, for neighbor and weight in graph of node, new cost is equal to current cost plus weight, right? So if neighbor not in the distance map or new cost is less than distance of neighbor, in this case you update the distance the dist of neighbor to the new cost, just basically getting them updating with the minimum cost, right? So now you push this value into the heap. So heap q, heap push, priority queue pq, and we should have the tuple, which is new cost and the neighbor, right? So now we will go ahead and return the distance map. Yes, let us run it. There are few typo or mistakes here, so because of that it was giving an issue. This should be a tuple, these two should be a tuple here, and we did not never initialize, created a variable here, total. So total is equal to 0. We have to initialize the variable. And then one more major part where I'm missing here is this should be min cost of s, because that is a map where we are checking in. It's not the complete map, right? So it's basically we are the source to target. So in that case this should be min cost of s. So now this will run without any issue, and let us submit it. And yeah, this is working and pretty efficient solution. Talking about the time complexity, this will take big O of the time complexity will be big O of 26, since we are using the map and traversing within the map, right? This particular will take 26 times, and distros will take e log v, which is e is edge and log v is the vertices or the nodes, right? So this will be the time complexity. And also now we have to look into the space complexity as well. So distros will eventually take e plus v, and this map will have 26 space, so this will be space complexity. Sc will be big O of 26 plus e plus v. So that is it. Thank you.